Good morning, good afternoon, and welcome to this conversation on 3.5 CBRS dynamic spectrum sharing. This is part of a report by Sense of Feeling collaboration with RCR Wireless News. And today I'm talking to Scott Imhoff, who is the Senior Vice President of Product Management at Cambium Networks. And I'm very excited about this interview because they're a company that provides solutions for using 3.5 in the US, and they're doing that already. So they're one of they're supporting solutions to the legacy users of the band. And they're excited to see what are the opportunities, the new opportunities that CBRS in the US is providing for users in this band. So Scott, thanks for being with us today.
Absolutely. It's a pleasure to be here with you, Monica, and your guests.
So to get started, can you give us an introduction as to what Cambium is doing and has been doing in the last few years, and what is your personal involvement?
Certainly. Let me start with an introduction to Cambium Networks, and then I'll touch on my own roles and responsibilities. So Cambium Networks connects the unconnected, people, places, and things. We do that using fixed wireless networking, and we offer those solutions globally. We're deployed in over 150 countries and have in excess of 10,000 customers. The customer base is diverse. We have service providers providing residential access. We support municipal government and smart city implementations, defense and national security, industrial applications in oil and gas, electric utility, and water management, as well as the enterprise space. Our solutions architecturally are point-to-point, point-to-multipoint, and Wi-Fi. And we utilize unlicensed spectrum, licensed spectrum, and soon with CBRS shared access spectrum. And we have a variety of capacities and capabilities, from kilobits of data for SCADA networks using narrowband radio to multi-gigabit solutions using licensed microwave and FDD implementations. Myself, I lead the product line management team here at Cambium Networks, and our charter is really to set the roadmap direction for our products and our platforms. So we work very closely with our end customers, the network operators themselves, our partners around the world, the system integrators and distributors, as well as our development engineering teams to identify opportunities, to solve problems, and really to bring the best solutions forward to our customers that we can.
Mm-hmm. So what does CBRS mean to you? How do you see it within your roadmap?
Sure. So CBRS is pretty interesting and exciting for us from a number of different perspectives. First of all, the existing 365, 50 megahertz of spectrum that is available in the United States is used extensively by a variety of different customers, primarily ISPs providing residential service. But again, municipal governments and industrial applications are utilizing it as well. And as I think you and all your guests are aware, spectrum as a natural resource is limited. And the more spectrum we have, the more solutions we can bring forward, and there's certainly demand for it. So we're looking forward to that additional 100 megahertz of spectrum that collectively with the existing 50 megahertz makes up the CBRS band. In terms of what it's going to do, it's going to enable higher capacity, more reliable service to a broader range of customers. And again, residential access, I believe, will be the primary access or primary utilization of that spectrum. But I also expect greater utilization by industrial customers, municipal government, particularly with the advent of the priority access licenses, the PAL.
Yeah, so basically it's more spectrum, more use cases. But maybe before we get into that and talk a little bit in more detail, can you tell us what is it going to mean for you in terms of your solution? How are you going to need to change it in order to have it work to follow the CBRS new CBRS regulations?
Sure. So first and foremost, it's important to note that there's a very large installed base of operators utilizing that existing 50 megahertz of spectrum. So top of mind for Cambium Networks is to ensure that existing customer base can continue to build out their networks during this transition period, have access to product, have access to solutions, and can support their customer base, which we are doing and continue to support. So for example, we just introduced a 3 gigahertz PNP 450i platform that operates in the existing 50 megahertz of spectrum and supports the broader range, the full 150 megahertz. Second, you have to be able to integrate into the SAS architecture, the shared access spectrum architecture. And we've been working closely with SAS providers to ensure that we have not just a single solution, but multiple options for that customer base, and to ensure that that existing installed customer base can migrate their existing solutions and retain that capital investment that they've made. So from our standpoint, the most significant investment is the SAS integration. Second is to ensure the ability to migrate that installed customer base.
So there are two aspects here. You need to integrate with the SAS for basically the general users, so PAL users that are the new users, basically, right? And then on the other hand, you also need to make sure you have a smooth migration for the legacy users. Can you tell me a little bit about what is the transition for the legacy users? What is that going to mean, and how can it be seamless?
Sure. So of course we're waiting on the finalization of the rules and the model, et cetera. So you can't be absolute in any statements before that takes place. But our expectation is through a over-the-air firmware update to existing infrastructure and CPE devices, we'll be able to migrate those existing customers with existing equipment to a SAS architecture.
Okay, so basically, and because they have a priority over everybody else, they're going to be allowed to continue to use whatever solution they have. They cannot be forced into obviously changing what they have, right?
Yeah, that's an interesting point. So you're correct that there is a defined migration schedule, if you will, for that customer base or that installed base. But I think CBRS and SAS does offer some opportunity that might be an incentive for that installed base to migrate faster than what they're actually required to do so. So I think you'll see a combination of some network operators that move quite quickly, particularly in urban environments where spectrum is tight, or they want to utilize and offer PAL-based service level agreements. But I also expect that there'll be some network operators that follow the defined schedule that the FCC has published.
Mm-hmm. Right. So I guess it's interesting because you can be a legacy user, but still want to use the new features, the new spectrum available. So you need to integrate. So it's entirely up to them, what depending on what requirements are.
Correct. And as I said, I do expect a hybrid approach. Some network operators will move. Some network operators will delay that shift until absolutely necessary.
Yeah, and at the same time, you're going to be able to work also with the new other PAL or general access operators that are not legacy users. Absolutely.
Our intent is to offer out of the gate a fully CBRS compliant SAS enabled solution. So we're working closely with WinForum, and we're following the development of the rules and the regulations. And as soon as they're finalized and available to the market, we intend to offer our solution.
Absolutely. So now, and is that going to be LTE based?
I'm sorry?
Is it going to be LTE based?
No, today we offer a proprietary solution that is an alternative to an LTE based architecture. So our initial implementations of CBRS and SAS will follow that Cambium architecture.
Mm-hmm. Well, and it's interesting because oftentimes CBRS is labeled as being LTE based, but it's actually technology neutral. So, which is actually very interesting in terms of allowing greater choice depending on what the operators want to do.
Absolutely. You're absolutely correct. It is technology agnostic. It is not specific to LTE, although certainly there will be LTE-based solutions in the marketplace taking advantage of that 3.5 spectrum. From our perspective, there's pros and cons. Clearly, a standards-based solution has multi-sourcing options, a variety of manufacturers, et cetera, but you're constrained by the standard itself. Let me give you a great example. In October of last year, we introduced multi-user MIMO, in fact, massive multi-user MIMO in a 14 by 14 architecture. LTE, the standard, defines up to an 8x8. So in October of last year, we've already started to ship 14x14 at 5 gigahertz, to be clear. But our intention is to introduce that same technology at 3 gigahertz. So we're able to provide alternate approaches outside of that standard and be more aggressive in development of capabilities.
Mm-hmm. And that might be particularly interesting in the case of private networks, where you do have a more contained type of network, but sort of by definition, and the need to have an LTE core might be put a burden on the operator. So for like private networks, industrial IoT, that might be a good solution for some of the players.
Absolutely.
Now, and you mentioned that as an interesting new area. How do you think that 3.5 and CBRS is going to work in industrial IoT type of environment?
Well, there's three categories broadly. There's the incumbent, the priority access license, and the GAA. I think what's particularly attractive about CBRS to the industrial space is the priority access license, where they have a higher level of confidence in access to capacity, specifically the carriers, and they're going to be willing to make that investment for PAL licenses to have the assurance and be able to commit to a service level agreement. So I expect that there'll be a combination of use within the industrial space. I would expect what they would consider their mission critical control messaging to use PAL.
Mm-hmm.
I expect non-mission critical, perhaps video surveillance or other applications, perhaps Wi-Fi access at remote sites, to use the GAA. So a combination of the two license types will be utilized by those industrial customers as well as municipal customers.
Mm-hmm. Yeah. Well, what do you see the municipal, what kind of scenarios do you have in mind for municipal customers?
Sure. So probably not much different than what they're utilizing fixed wireless for today. Very large deployments of video surveillance. That's ongoing in municipalities, large and small. Is the deployment of video surveillance in public spaces, other high crime areas, et cetera. And video is ubiquitous today. Power is readily available, but the backhaul of that video tends to be the challenge, and they're turning to fixed broadband as that transport medium of choice. And so I see CBRS serving that need. I see it being used in intelligent transportation systems. Many municipalities operate their own electric grid. Many municipalities operate their own water management systems, so freshwater delivery, wastewater collection. So the supervisory control and data acquisition applications in that space could take advantage of CBRS. Very simple delivering broadband access to remote facilities. So if it's a park district and they want to bring broadband to concession stands for credit card processing and other applications, I can see CBRS being used for that as well.
Right. So this would be both for backhaul and access, or primarily?
Correct. Architecturally, we make no distinction between the two, other than perhaps the capacity required on that particular path. So access and backhaul or transport.
Yeah, I guess it's the same. It's just a topology issue at some point.
Topology and capacity.
Yeah, the different requirements. Now, in terms of other use cases, obviously residential is going to be a crucial one for you as well, right?
It is. Network operators, ISPs, providing residential access is a significant portion of our business. Our networks are optimized for residential access. There's been an ongoing shift into triple play services. So, historically it was simple internet access, surf the web, etc. They started to pick up voice circuits, voice services across those paths, and now video delivery really dominates the capacity. And as those cord cutters continue to accelerate, triple play is really here to stay.
Yeah. So in that case, having the additional capacity is going to be a huge advantage even for the incumbents.
Absolutely.
What about the enterprise?
Enterprise, it'll be interesting to see. Certainly, there's been a lot of discussion with the industry around small cell and shared spectrum, where perhaps voice is on the traditional licensed cellular networks, whereas data transitions to 3.5. So it'll be interesting to see what happens with small cell, and particularly in the indoor environment. I know there's a lot of activity there. Outside of that type of application, enterprises are using video surveillance, they're networking their facilities, they're bringing broadband to remote sites. CBRS will serve those needs as well.
Yeah, so I guess it's for both for the general access which you currently have with say Wi-Fi or cellular, but also but basically it's IoT applications, internal IoT is for the enterprise.
Certainly.
And wouldn't that make the enterprise keener to invest in the infrastructure itself, more so than they have been in the past? So for small cells, there is often an expectation that the operator come in and installs the infrastructure. But maybe now with 3.5, they're going to be more likely to take the lead in terms of investment as well.
I may not follow your question explicitly, Monica, but are you suggesting that enterprises will invest in private networks versus using public networks, or invest in indoor deployments of small cell?
But both. It's because they could actually be combined on the same infrastructure. So they could have a 3.5 CBRS network that can be used both for their own private networks or so IoT applications, and then also have it used for access in a neutral host type of model.
That's true.
And for edge.
So we have seen, interestingly enough, we have seen some enterprise customers, particularly those with large geographic footprints, where they're building private networks, but they've recognized that those private networks can serve not only their needs, but the needs of the broader community within their geographic area. And they're starting to open up those networks and providing services to their neighbors, and in some cases on a for-fee basis. So they're taking what might be considered a cost center and turning it into a profit center, meeting their own operational needs and requirements, but also providing broadband access and transport to third parties on their network.
Right. Now, in terms of coexistence, when you talk about sharing spectrum, you can imagine that the legacy users would be worried about it because, yes, they get more spectrum, but they also get more contention for the spectrum they have. Is there any worry that you can see from the legacy users in terms of potential interference and things like that?
Well, in part, that's the purpose of the shared access spectrum. It's the purpose of the SAS architecture. It's the purpose of, from a regulatory standpoint, in the set-asides to protect that legacy installed base. So I think it's natural to have concern. And if I were one of those incumbents, I would certainly be interested in understanding the deployment model, the architecture, the schedule, et cetera. But I think the FCC and Wind Forum have done a very nice job, or are doing a very nice job as it progresses through the process, to ensure that those incumbent users are protected and that they're able to provide the services that they've historically provided, and that there's a graceful migration where appropriate for those installed legacy networks.
Yeah. So now when we look at the spectrum sharing, it happens. It's dynamic compared to what we currently have, in the sense that it changes through time, but it's not really real time. So it's still in the matter of hours or maybe minutes. Do you think that moving forward is going to be even more dynamic? That it's going to be, you're going to have switch users more frequently, or you don't see that being an issue?
Well, technology will evolve. The robustness of the solutions and the networks will evolve over time. And in terms of efficient use of that natural resource, the more dynamic you can make it, from my perspective and Cambium's perspective, the better off we're going to be. But I think you need to pace that evolution with confidence in the technology. So I definitely see shared access spectrum and dynamic allocation of spectrum becoming the default really for almost any spectrum utilization, because it's efficient. And you, at an industry level, at a societal level, the more efficient we can use that natural resource, the better off we're all going to be. So I see that transition, that migration, that trajectory, if you will, it'll be paced with technology and confidence in the technology to support it. Yeah.
So if we look at it beyond the US, beyond CBRS. What do you see happening? What are the prospects? Because this is clearly, CBRS is going to open the doors for a lot of innovation. What are the next steps?
Well, from our own experience, and as I said, at the very beginning of this interview, we operate in over 150 countries. We work very closely with regulatory bodies around the world. There are many, many entities watching the rollout of CBRS. Many regulators around the world are watching the FCC and the implementation of CBRS with a very optimistic perspective that, hey, if this works for the United States and the FCC and that customer base or that network operator base across the US, I think you'll see rapid global adoption of that model. Again, and it goes back to efficient use of the spectrum. They can provide more services to a wider range of network operators and end customers, bring broadband to a far wider population the more efficiently they use it. So lots of regulators are watching. I think there's general optimism in the model. And as soon as there's proof positive of its adoption and its application, its use, you'll see global adoption.
Mm-hmm. So this is so CBRS opens the more opportunities for spectrum sharing, but at the same time, there is a lot of interest in the 3.5 band worldwide without sharing. So 3.5 in many countries, especially in Europe, is seen as a 5G technology. How do you see that impacting what you're doing at Cambium?
Well, that's a good point. And 3.5 or 3.65 in the U.S. was effectively unlicensed. It was managed spectrum, but there was no real cost associated to utilizing that spectrum. And when you look at the additional 100 megahertz of spectrum that make up CBRS, the introduction of the PAL license does introduce monetization of that spectrum to a certain degree, but the FCC has set aside a large block to be fee-free. If you go outside of the U.S., many countries assigned 3.5 for WiMAX implementations back in the day, and it was licensed spectrum, and it was purchased, there was investments being made by network operators that hold that spectrum today. But I answered that prior question not specific to 3.5. I think the concept of shared access spectrum, dynamic allocation of spectrum, is band independent. It doesn't really matter what RF band you're operating on. Now, clearly, if you're a network operator and you've invested billions of dollars in purchasing spectrum, you're not going to be, beating the drum to give it back and have it allocated as shared access spectrum. You're going to want to hold on to that spectrum because you've made an investment, you've invested in infrastructure, et cetera. But where that doesn't exist, where new spectrum becomes available or spectrum is refarmed for net new purposes, for example, the transition from analog to digital TV has freed up lots of spectrum around the world. I think SAS is a natural architecture for efficient use of that spectrum.
Mm-hmm. Yeah. No, I think it's going to be very exciting to see moving forward how the spectrum sharing is going to, as I say, become the default because it's more efficient. Well, Scott, thank you for sharing your thoughts with us today.
Absolutely. I really appreciate the opportunity to tell you a little bit about Cambium Networks and what we're doing. We're really looking forward to the commercial rollout of the SAS system, and we're looking forward to the broader adoption on a global basis of that same architecture.
Absolutely, yeah, and we hope it's happening soon and see what happens, because it's going to be very exciting to see what we can do with that. Well, thanks. This was an interview as a part of a report on 3.5 spectrum sharing and CBRS in the US. And thank you all for listening in.